Hello everyone. Last week I did a live presentation on Linux virtual networking, and my focus was actually MACVlan and IPVlan, but I ran out of time and I kind of rushed it at the end, so I decided to do another presentation recording, especially for MACVlan and IPVlan. Actually, only for MACVlan and IPVlan. So let me get to the drawing board, and let's start with MACVlan. Um, as you might already know, MACVlan is like a simplified bridge. Um, so let's see the details. Let's consider we have our Ethernet interface ETH0, and this would be the master interface for the MACVlan construct. So this is our MACVlan configuration where we attach interfaces. Let's say we have here Mac if 1, and then we have another interface here, Mac if 2, and of course we can put these interfaces in a, actually this is the thing with MACVlan. We can put these interfaces in a dedicated namespace. So let's consider that this Mac if 1 belongs to namespace 1 here, and the second interface, Mac if 2, belongs to a different namespace, namespace 2. And these interfaces will be able to communicate. They will forward also broadcast and multicast, and this is an important thing. But if we want to communicate with the default namespace, the one in which ETH0 operates, we can do that only if we have a MACVlan interface in the default namespace. So let's say let me change the color. We add another MACVlan interface here, Mac if 0, and this would be the default namespace. And as I already told you, the MACVlan construct will forward frames in between all of these MACVlan interfaces. It's like a bridge or a switch that doesn't do dynamic learning. It has a fixed cam, and it also doesn't do spanning tree. So it's a very simplified switch. And if we want to bring things a little further, we can consider actually that this ETH0 right here, it's also a virtual interface of it's an interface of a virtual box machine. Let's say I have a virtual box machine where I will demonstrate this setup. So let's say that all of this that I have drawn until now, it exists inside a virtual machine, a virtual box machine. So this ETH0 is an interface the virtual machine. And we can also communicate with the physical network if this ETH0 is bridged with, let's say here we have a PHY0, a physical interface, and if this is bridged with ETH0, frames from this host right here will be able to reach any of those namespaces or the default namespace on the MACVlan interface. So this is the high level picture of how MACVlan works. So let's put a couple of things here. I said it's like a simplified bridge or a simple bridge. No STP. It does broadcast and multicast. And another thing which is important and very often is forgotten, ETH0 has to be in promiscuous mode. In order to be able to communicate with the physical network. So if we want our host here on the physical network to communicate with MACVlan interfaces, ETH0 needs to be in promiscuous mode. This, let me write it down. This needs to happen because you have to imagine that behind ETH0 there are multiple MAC addresses, so it has to accept frames for other MAC addresses than the ones that it has. So what else? These are pretty much the important things. It is also a thing with scalability. The extra overhead for that software bridge is adding with STP and dynamic learning. It starts to show when you have, like, I don't know, hundreds of containers. So what I will do now is go to a console and show you here a couple of things. Actually, configure the setup I have drawn previously. I'm not going to insist with MACVlan modes. There are 4 modes, as you might know. There is private, VEPA, bridge, and pass-through. We are only going to discuss about the bridge mode, which is the only one supported by Docker. So let's get started. First, let's see what links we have. I will use this one as the master interface. But I will use a different IP class. So what I will do, I will create 2 MACVlan interfaces, which I will after put in dedicated namespaces. So IP link add. I will use as the master interface ENP0S8, and the name of my first MACVlan will be interface will be MACVlan, type MACVlan, and here at this point I have to specify the mode of the MACVlan, and I don't know how to specify that, which is the syntax. So if I type something here randomly, it will give me actually quite a good hint about what I can type. So mode should be one of these words. I can also type help if I want, and it's giving me the same thing. So what about the default mode if I don't type anything? Let's try that. It has created the link. I don't know what MACVlan mode is this, because it's not showing me. How I can display that if I use the detail flag and I use type MACVlan to restrict the output only to the MACVlan interfaces. And as you can see, the mode is VEPA, which is not what I want actually. So I will delete my MACVlan interface and create it again. S8 one type MACVlan and mode. Now I will say bridge. So let's see the created link. This one is, which as you can see it's in bridge mode. Let me create the second one, and let's check our progress. Let's only display the MACVlan interfaces. So I have two MACVlan interfaces which are in bridge mode. Now let's create the namespaces for them. Let's display IPNetNS. I don't have any namespace created. I will create two namespaces right now. MACNS1 add S1, MACNS2. Here they are. Now I will move the interfaces in the dedicated namespaces. IP link set MACNS1, and I will move the other one to MACNS2. Now I want to configure the interfaces inside the namespace. So there is this command exec network namespace exec, which gives me the possibility to execute a command in the context of the specified namespace, like this one, MACNS1. So whatever I will type right now, it is executed in the context of the MACNS network namespace. So if I go with IP link show, it's only showing me the loopback interface of the namespace and the MACVlan interface that I have created and put here in this namespace. I will bring the interface up. Link set MACVlan up, and I will add an address to it. sorry, the Mac one. So let's check our progress. Sorry, exec Mac NS. So I have this. Let's show the address also. So we are good until now. Let's go to the secondary interface. IP link set Mac if2. I will bring it up and I will assign an IP address. Address add 192.168.120 Mac if2. Let's check our progress. So we have this. Right now we should be able to ping from one namespace to the other. Let's do that. I will ping from Mac NS1, the interface in Mac NS2. So sure enough, I have replies. So what if I want to communicate with the default namespace? I just have to create a MACVlan interface in the default namespace. So let's do that right now. Also with the ENP0S8 as the master interface. Let's name this one MACIF0, type MACVlan mode bridge. So here it is. Let's bring it up and assign an IP address. Let's say this one. And now from the default namespace, let's try and ping one of the namespaces. So as you can see, it's working. So if you don't believe me that things are really happening like that, let's try something. Let's do a demox session and do a split panel like this. And in one of the panels, I will start a TCP dump in namespace 1. Let's say IP net exec Mac ns1 TCP dump Mac if1. So right now I'm sniffing with TCP dump in network namespace Mac ns1 on the Mac if1 interface. And I will, sorry, right from here, from the default namespace, I will ping the address of that interface. And as you can see, I have pings. So what if I want to communicate with the physical network, as I shown you, as I have shown you in the drawing board. Let's do this. And let's see the interfaces that I have here. So my VirtualBox machine is bridged with this interface, which has this IP address. So I will add a secondary IP address here from the same class as the one configured in the namespaces. Let's say 100, 100. All right. My goal here is to have a directly connected network, or to have this network as a directly connected network. So let's display the routing table. 192. I don't think this is correct actually here. Let me try and add a root manually. And I should specify the interface, but I don't know exactly how to do that. Let me one, two, three, four, five, six, seven. Maybe it's interface 7. I don't know. Let's try it. F7. What? Okay. I don't know Windows routing, so let's do it like this. So 100, 100. The object already exists. Blah blah blah. What should I do? My problem right now is that the SSH session is connected on this interface, so I don't want to break that connection. I will do it like this. This 100.1 is the MACVlan interface in the default namespace. Actually, this is an extra hop, or the way I have configured the route here. It's just Windows. It has this weird behavior. What I want to show you actually is something else. Let's try and ping one of the namespaces, one of the IP addresses from the custom namespaces. So ping 100.10. So it's working. Okay. It's not actually what I was expecting, what I was expected, but let's ping it again. Right now it's working actually. Why? I expected it not to work actually because I wanted to show you something. Um, Sorry. Okay, show. I will show the details of this master interface. S8, blah blah blah. I wanted to check if the promiscuity on this interface is activated, and it is activated. I might have done this previously and forgot about it. By default, is not activated. Let me exit out of this Tmax and check again. IP link, IP detail link, show enp0s8. So promiscuity 1. If I change this, off, actually it hints me about the argument. So now promiscuity is 0, and if I'm trying to ping it, it's not going to work. What I actually wanted to show you and surprise you was this thing. If I'm doing a TCP dump, this is how I discovered it actually after some trial and error. TCP dump minus inp0s8. Let's say I'm capturing for network 192.168.100.024, and right now when I'm pinging, it's working. Let me do a continuous ping. But when I'm stopping TCP dump, look what happens. It doesn't work anymore. And why is doing this? Because TCP dump by default, when it starts, it puts the interface in promiscuous mode. So that's why TCP dump, uh, or with TCP dump, we get this behavior. When I first read about MACVlan and I started and constructed a lab, I missed somehow this information that the master interface needs to be in promiscuous mode, and I lost a couple of hours trying to find the solution and why TCP dump is it's doing this, and with TCP dump started, it's working. All right, so I think we have enough for for MACVlan. I want to do also IPVLAN, but I will do it in the next episode because I don't want to bring too much information all at once. So thank you. I hope this has been helpful for you guys, and see you in the next episode. Bye bye.